In today's video, we'll explore the birth of derivatives. We'll break into 3 case stages, tracing how the simple idea of slope evolved into the powerful concept of derivatives. From constant rate of change to average rate of change and the limit of rate of change. We know for linear functions, the graphs are lines. Slope doesn't change everywhere on the line. For nonlinear functions, the graphs are curves. The rate of change varies. It depends on your choice of points. It's not constant. As h approaches 0, that means 2 points get closer, almost merged into 1 point. Such a limit of average rate of change is the definition of the derivative. We have 2 notations. F prime of x is a Lagrange's notation, and dy over dx is a notation by Leibniz. So the discrete change tends to be infinitesimal change. If you are interested, you can do more reading on the evolution of derivatives. Here is the Leibniz notation dy dx and the history of the calculus. Graphically, moving from the average to instantaneous rate of change corresponds to transitioning from a secant line to a tangent line. To visualize this concept, we'll use Python. Let's begin by importing the necessary packages. NumPy, Matplotlib, Fun Animation, and the class HTML. Let's take a look at the Python code. Here I choose a simple function, a quadratic function, f of x, and its derivative function, f prime of x. For plotting, you can choose any interval in the domain and any number in the interval. Here I choose the interval -2 to 4 and the point x at 1.4. And we set up the plotting canvas size 8 by 5, draw some points and put the labels, and this is the animation function in the interval -2 to 4. Let h start from 3, and the secant line, tangent line. Let's run the code. First, you go to this cell, click Run. So import all the necessary packages. Then let's run this cell. So as h approaches 0, P2 merges with P1, causing the secant line to become the tangent line. The orange line is the graph of the derivative function f prime of x. Here, f prime of x is a linear function, a line. Each point on the orange line gives the slope of the tangent line to the original function at that same x value. So this y value of this orange point is the slope of the green tangent line. In other words, the derivative function f prime of x is a collection of all the slopes of the tangent lines to the original function for all x values in the domain.